The pop quiz which was related to electricity, magnetism, atomic, and the space physics. You can also use chat, mic, or screen annotation to answer these questions. An electric circuit contains a battery and a fixed resistor, a voltmeter, and a thermistor. Figure 7.1 is an incomplete circuit diagram of the arrangement as you can see. The thermistor is connected between the terminal T1 and T2. Complete the figure 7.1 by drawing the symbol for the thermistor. So we have to draw the thermistor, that's right, this is a symbol of thermistor. And whenever two resistors are connected in series, this type of a circuit is known as the potential divider circuit. Two or more resistors or components are connected in series. So we call that as a potential divider circuit because the potential or a voltage will divide between the two components. The resistance of R is 2.5 ohm and the reading of the voltmeter is 0.4. We need the current. So we have the voltage and resistance. We have the voltage and resistance and we need current. How we can work out the current? So current I is equals to V over R as V is equals to IR. So current is a ratio between voltage and resistance. The voltage is 0.4 and the resistance is 2.5. So 0.4 divided by 2.5. That is 0.16 ampere. Then the power, if you need the power, you have the voltage, you have current, or you have resistance. So different formulas of the, three different formulas of the power are there. P equals VI, P is equals to I square R, or P is equals to V square over R. So any one of them you will use, you will get the same answer. P equals IV. So you have the current from your previous answer, 0.16. So 0.064 watts, right? So 0.1 multiplied by the voltage, which was 0.4, you get 0.64 watts. The temperature of the thermistor increase. What happened to the reading of the voltmeter? Look, as I mentioned, it's a potential divider circuit. So we have a fixed resistor and we have a thermistor here connected between T1 and T2. Now, as we increase the temperature, what happened to resistance of the thermistor? If we increase the temperature, so resistance of the thermistor will decrease. So if the resistance of the thermistor will decrease, what happened to voltage across thermistor in series circuit? So if we have so what will happen to the reading of the voltage across the thermistor? That will decrease. So in comparison, because it's a potential divider circuit, if one side voltage decrease, the other side voltage should increase. So even though this resistance is not changing, but the ratio of the resistance change, that's why other side will have a high voltage or the voltmeter reading will increase. So the points which we have to mention, like increase in temperature, decrease the resistance of thermistor, which reduce voltage across thermistor and increase the voltage across the fixed resistor. So in a potential divider circuits or series circuit, if one component, the voltage across one component increases, the other component it will decrease. This question is related to magnetism. Figure 8.1 shows a permanent magnet attached to one end of an unstretched spring and held at rest just above the solenoid. The solenoid is connected to sensitive ammeter. State the name of a substance from which a permanent magnets are made. So permanent magnets are made up of steel. That's right. Steel is a hard magnetic material, so permanent magnets are made up of steel. The magnet is released and moves downward towards the solenoid. Ammeter shows that there is a current in the solenoid when the magnet moves. Explain why there is a current in the solenoid. So you have to explain what? You have to explain the electromagnetic induction. So what is the electromagnetic induction? Change in the magnetic flux induces EMF. And one more thing, whenever the circuit is complete, then only it produces a current. So change in the magnetic flux, change in the magnetic flux linkage. How you score the 3 marks, the distribution of the marks for this one. The first thing you will mention, there will be a change in the magnetic field, or the magnetic field lines cut by the solenoid will change, or magnetic flux linkage will change. That will induce a current. Induce EMF, or you will mention current. This is the electromagnetic induction. That change always produces a current. The, the current causes the top end of a solenoid becomes south. The bottom end of a permanent magnet is a south pole. Explain why the top end of a solenoid become like the south pole of a magnet when it moves downward towards. So as we know, according to electromagnetic induction, EMF induced always oppose the change. What does it mean always oppose the change? Like when we are moving the magnet towards, the strength of a magnetic field is increasing. So what this solenoid will do, it will try to oppose. So how it can oppose? By producing a opposite pole, like pole, which repel each other. So this will be south, this will be north. But if the same magnet was moving upwards, the magnetic field strength, there will be a change in magnetic field. It will induce a current, but the strength of a magnetic field is decreasing when it is going up. So it will try to oppose the change. Then this side will be north and this side will be south. So always the induced EMF always try to oppose the change in magnetic field. So the reason for this one, you will mention like the EMF induced always oppose the change in magnetic field or resist the change in magnetic field. By producing current in opposite direction. So when the magnet is moving, when south pole of a magnet is moving towards the solenoid, it oppose by producing south pole on the solenoid. So always remember the induced EMF always oppose the change. So if we have a solenoid and we are moving a magnet towards the north pole, so what pole will be here? If I'm moving a north pole towards the solenoid, the strength of magnetic field will increase. Which pole induce here? When we bring a north pole, so this will be north because it will try to oppose, and this opposite will be south. But opposite will happen if the same magnet and we are moving it away. So which pole it will induce? Because the strength of magnetic field is decreasing, so it will try to oppose that by producing opposite pole. The magnet oscillate up and down. What happened to the current in the solenoid? So this magnet is oscillating up and down. It will continuously change the direction. Yeah, continuously change the direction. And the magnitude you can also, because 2 marks are there. One is continuously change direction as well as magnitude, the values. So 1 mark for mentioning continuously changing direction, 1 mark for mentioning continuously changing the magnitude. Or the needle of the voltmeter or galvanometer will oscillate to and fro. Question 3. In space, an interstellar cloud of a dust and gas collapsed to form a protostar. The cloud contained hydrogen. Describe the energy transfer that take place as the cloud collapsed to form a protostar. What is the energy transfer? Like the cloud is collapsing, like it has a larger size and it reduces the size. So what is the energy transfer here? First it has a large size, then it reduces the size. So initially what happened, it will have gravitational potential energy. You don't have to, because energy transformation is we need. First it will have a gravitational potential energy and the gravitational turn into kinetic. And also produce a heat energy, and that heat energy, the kinetic energy turn to heat energy, and that heat energy increases the temperature of a protostar, which start the hydrogen fusion. So we don't have to mention the nuclear one, like this part we don't need. So the energy transformation here first, because they said it has collapsed. So we'll have GPE, the gravitational potential energy, changes to kinetic energy, and the kinetic energy changes to internal or heat energy, which increase the temperature to start hydrogen fusion. Or you can also mention like GPE turn into GPE and KE, and that convert into internal or heat energy. So this is always the case. That's how we explain the cycle of the star, by explaining the energy transformation from gravitational to kinetic. Whenever it collapsed, the GPE turn into KE. And then KE, the kinetic energy, particles move faster. So as a result of a collision, it will have a heat energy as well. The collapse result in a nuclear reaction in a protostar that involves an isotope of a hydrogen 3,1, and hydrogen 3,1 is a radioactive. It decays by emitting a beta emission. Show that the nuclei of isotope, state how the nuclei of isotope of same element are different. So they will have a different number, neutron numbers in the nucleus. Yeah, different number of neutrons. Explain why hydrogen 3,1 cannot decay by alpha. Why it cannot emit alpha? Because if it is emitting alpha, then what should happen? It should release 2 proton and 2 neutron. If you check hydrogen 3,1, it has 1 proton, it has 2 neutron, and it has the nucleus. This we talk about nucleus. Yeah, it has less than 2 proton. That's a good. Or you can also say it has only 1 proton. That's also fine. Or does not have 2 proton. That's correct. Or because it has only 1 proton. That's also fine. Complete the equation for the decay of a hydrogen to an isotope of helium. It's a beta decay you have to complete. When it's a beta decay, the nucleon number does not change and a proton number increases by 1. So this will remain 3 and this increases by 1. So that's helium. This will be an isotope of the helium. The normal helium we have 4,2, but this is an isotope which is 3,2. Explain how the nuclear reaction in a protostar stop further collapse as a protostar become a stable star. So what actually happened when the protostar become a stable star? What are the terms you have to use? One thing you have to use a term radiation pressure, which is outward. Another thing is a gravitational force, which is inward. So what happened when the star collapse? When the initially when the protostar, like it is forming a protostar and collapse, it started a nuclear reaction because of the high temperature. Forces are balanced, 1 mark, and outward force, the radiation pressure equals to gravitational force, that is the second mark. But how it all started? So you have to mention the nuclear reaction, because as the star was collapsing, it started a nuclear reaction in the core, and that nuclear reaction produces the radiation pressure outward and the gravitational force is inward. The forces are balanced, that's why the star does not change the size. So if the outward pressure due to radiation equals to inward force due to gravitational force, that will score 2 marks. But what about the starting point? You have to mention that the nuclear fusion actually started and that nuclear fusion released the energy. And that energy caused the outward pressure, or we also call a radiation pressure. So 1 mark for radiation pressure, 1 mark outward, or you can also say balance, and 1 mark is for mentioning inward force. The cloud of dust and the gas then collapse and also contain atoms of the heaviest elements. State which part of a life cycle of a star is responsible for production of the heaviest element. The heaviest element produced in the supernova. Actually, you have to use the term supernova rather than red giant, because a supernova, that is a stage which produces the heaviest element. Or if you are saying a red giant, just use the term red, don't only say red giant, it should be red supergiant. So red supergiant explode or explosion, that, or a supernova you can also say. So either mention red supergiant or a supernova. If you mention only red giant, because red giant is for low mass stars, it does not produce enough heavy metals. When we talk about the stars, the star cycle, for the massive stars, supernova is actually the name of the explosion which is given. So first you have a main protostar is there. Then you have a main sequence star. If you talk about the heavy metals, like the high mass stars, then we'll have a red giant or red supergiant, which we also call. And then we have a supernova. So in a red giant, which fusion was happening? Helium fusion was happening. In a main sequence, mainly hydrogen. And this also hydrogen was about to start. But in supernova, how supernova happened? When the red giant, like we have a red giant, when this red giant start to collapse, because the helium fusion cease or reduce, when the red giant start to collapse, the temperature of a star increases too much, and that temperature increase in temperature start what? It start a new fusion of the heavy element like helium, carbon, oxygen. They start to fuse and explosion happen. So when the supernova occurred, supernova happened because of the fusion of the heavy elements, like forming other heavy elements. So if we say a red giant, the stage of a red giant, when it start to collapse, the supernova happen. The moment supernova happen, that is the time when it start to produce the heavy elements. So the precise answer should be supernova. But red supergiant is acceptable because red supergiant was collapsing and then it produced an explosion, which we call a supernova. Is it clear? So supernova is explosion, but that explosion is because of the red supergiant. When they start to collapse, they start to form the heavy element, and then the star is not, the radiation pressure is so high that it cannot hold anything inside. And that explosion, which we call a supernova, bright enough to work out the distance of the galaxy. In question 4, the isotopes of iodine 131 emits two types of nuclear radiations. Gamma radiation is one of the type emitted. A sample of iodine 131 produce a narrow beam of radiation which passes into a magnetic field. Figure 10.1 shows the path taken by in a magnetic field by these radiation. The figure of a magnetic field is into. On a figure, mark with a symbol for a gamma, the path that it's taken by the gamma. Which one is the gamma, path of a gamma? So this one, because a gamma does not deflect. So straight line is representing a gamma because deflection does not happen or occur for the gamma. Then determine the other type of radiations emitted from iodine 131. So other type of radiation are when you apply the rule, like example, if you work out the left hand rule, according to left hand rule, Fleming's left hand rule, your index finger, your first finger or index finger will point into, your second finger represent the direction of the particles which is moving. So if it was alpha, but if it was an alpha, the force is upward. If there was an alpha, it should go up. But this is not alpha, it is not following the left hand rule. So means it is beta. And we use the right hand rule and magnetic field is into, the radiation is perpendicular. So eventually it will move right angle. But why, another point, why different, even though all of them are beta, but why they have a different curvatures? That's right. They have different speeds. They have different momentums. That's why all of them beta. So the points which you will mention, yes, Rabia, that's a good answer. You mentioned this is about all the points, but one more important point that you will mention is that why they're taking different trajectories, even though all of them are beta, because they have different speeds or they have different momentums. So all of them in beta, one point is they have different momentum. That's why the curvature, the direction of the curvature is same, but amount of a curvature or amount of deviation is different. So all of them beta and they have different momentums or they have different speeds. You can mention that point. In another experiment, a beam of radiation from a sample is incident on a 5 centimeter thick sheet of lead. State what type state what happened to two types of radiation. If you use 5 millimeter thick lead sheet, 5 millimeter is a thin sheet, so thin sheet cannot stop all gamma. Beta won't pass, that's right. That's correct, the beta won't pass. But what happened? Gamma can pass because it's not a thick, because thick lead can absorb. So gamma still can pass, but it will reduce the amount of gamma. That's right. Gamma radiation produced, the gamma radiations produced has a frequency of 8.8 exponent 11 hertz. The speed of electromagnetic radiation in a vacuum is 3 exponent 8. What is a wavelength? Which formula we'll use if we have the frequency and the speed? The formula which relate frequency, speed, and wavelength. V equals F lambda. So if you need lambda, it will be V divided by F. So 3 exponent 8 divided by 8.8 into 10 to the power minus 19. 8.8 exponent 19. So this will be 3.4 exponent 12 minus 12 meter. And it should be a very small wavelength, because if you check the electromagnetic spectrum, gamma is having the highest frequency and the shortest wavelength. So the wavelength of gamma is shorter than any other in the spectrum. So this was a pop quiz which was related to space physics, atomic and electricity, magnetism.